Welcome to qnawire.
So now we'll work on problem 91 from chapter 13. In this problem, we need to classify, or we need to say how many moles of particles of solute would be present in 1 milliliter for some aqueous solutions. In the first sample, we're given a solution of copper sulfate. So in the previous problem, problem 90, we were talking about 1 liter of solution. So we didn't have to, we could say that the molarity equals moles. But here, that's not the case. So to get moles N, we need to multiply molarity times volume. And the volume should be in liters, so we'll multiply by 0.001 liters. So for copper sulfate, at the beginning here, we're given a concentration of 0.02 molarity. We need to multiply that by 0.001 liters to get the number of moles. Then to find the number of particles, we need to multiply by the Van 't Hoff factor, I. In this case, it would be 2 because copper and sulfate would break up into 2 separate ions in water. And so that means we would have 4 times 10 to the minus 5 particles. So actually it would be particle moles. So in part B, we're given barium hydroxide. Concentration is 0.004 m. We multiply by the same volume because we're considering only 1 milliliter. In the case of barium hydroxide, we would have 3 particles because we can see there are 2 hydroxides for every barium. So we multiply and we get a value of 1.2 times 10 to the negative 5th moles of particles. In part C, we're given pyridine, basically benzene with one of the carbons replaced with nitrogen. The concentration is 0.08 molarity. We multiply by the same volume. Pyridine does not dissociate at all in when it's dissolved in water, since it's a completely organic compound. So we have a value of 8 times 10 to the minus 5 moles, or particle moles. We only multiplied by 1 with pyridine because there is no dissociation for it. Finally, in part D, we're given ammonium carbonate, NH4 2CO3. The concentration is 0.05 m multiplied by 0.001 liters to account for the volume. And again, similar to part B, we have 2 ammonium for every carbonate, so we have 3 particles. So we do this multiplication and we get 1.5 times 10 to the negative 4 moles of particles.